The next one comes from Kenny. Okay, Kenny Mobeto gave us a question as well, which is a nice one. These are more or less asking the same thing, so I hope it's good revision for all of you guys to understand what you need to do. So let me draw that. There's my circle that we're dealing with here. I'm going to need to move it a bit lower. This one is a question that comes from Kenny. Kenny, I hope you're watching and you will understand what you needed to do in order to work out with this question. It's analytical geometry, no complications. The problem starts when they engage other concepts of math in solving these problems. There's a tangent on this. Okay, cool. Let's try to get that tangent, which goes something like that. Beautiful stuff. All right, we're happy with that tangent. And there's also the Cartesian plane that they have for us here. The Cartesian plane, let's see what the Cartesian plane is going to look like. It's passing somewhere there, so it's passing somewhere this side, right? There's where the Cartesian plane is currently located, and we've got this. We're all happy to see what we have right now. Right, and then there's another line here, which I'm also going to draw in blue, which goes from here straight to there. It's perpendicular, apparently, to the tangent that you're dealing with there. At the point where the tangent is tangential to the circle, we've got a point that is called P with coordinates -4 and 5, okay? This point here where the tangent cuts the x-axis is point S with unknown coordinates. The midpoint or the middle of the circle, the center of the circle is point M. And there's a point K here for Kenny with coordinates 0 and -3. Thank you very much, Kenny. And there's the origin, of course, and we've also have the x-axis here. Right there at the top, there's point R with no coordinate given, right there where the tangent cuts the y-axis. So the statement reads as follows in the diagram: point P -4 and 5 and K 0 and -3, the end points of a diameter of this circle with center M. S and R are respectively the x and y intercept of the tangent of the circle at P. Theta is the inclination of PK. Theta is the inclination of PK. All right, so there's an angle theta here. There's an angle theta here, which is the inclination of PK. New information is going to emerge from this question as well, right? With the positive x-axis. Beautiful stuff. The first question, Kenny, wanted us to do is work out the gradient of SR. SR, okay, that should be a joke. Where is S? There's point S. Where is R? There's point R. Now, if you are looking for the gradient of SR, you're looking for the gradient of the tangent, but we don't have information to work out the gradient of SR. However, we know that that tangent is perpendicular to the diameter. So if we know the gradient of the diameter, we can work out the gradient of the tangent. So what I'm going to say, Kenny, I'm going to say to the examiner, the gradient of the diameter, this is the gradient of the diameter, is the y value at point P minus the y value at point K over the x value at point P minus the x value at point K. Changing y over changing x. That is going to give me 5 minus -3 divided by -4 minus 0, which amounts to 5 plus 3, which is 8 over -4. The answer there comes out as -2. That's the gradient of the diameter, right? But -2, remember what I said, then we know that the radius, but the tangent is perpendicular to the diameter or the radius. Therefore, the gradient of the tangent multiplied by the gradient of the diameter must give us -1. This is what is important. This is what works almost 90% of the time in questions that involve analytical geometry, right? The gradient of the tangent and the gradient of the diameter, when you multiply them, their product will always give you a solution of -1, right? Which means then we can then conclude that the gradient of the tangent will be, like I said, if the first one was negative, the second one is going to be positive. If the first one was 2, which of course is 2 over 1, the other one is going to be upside down, which means it's going to be 1 over 2. And we're happy as the solution for the gradient of that particular SR, right? So I'm going to say examiner, therefore, the gradient of SR is 1 over 2. It's a half. Okay, now they want the equation of SR, the equation of SR, equation of SR. Okay, they want the equation of SR. What did I say? I said in order to find the equation of a straight line, the ingredients are you need a gradient and you need a point. Do I have a gradient? Yes, we found it. This is a story. I always tell people that when you're doing geometry, whether it's analytical or Euclidean, the questions form some sort of a story. The answer you get in number one plays a big role in the follow-up questions. And the answer for number one and number two will also play a big role in helping you to work out the solution to the third question, right? So why were these people interested in asking me to figure out the gradient of SR? Is because they knew they want me to find the equation of SR. Well, let's show them that we know what is going on here. So the point I'm going to take is any point that that straight line passes through, and it has to be point P because it's the only point which we have the coordinates for. You can't take any other point. It has to be a point where that tangent passes through, right? So I've got my ingredients. I can start cooking the equation. Let's cook the equation. Let me use a different format as opposed to the one we used first. So instead of using y is mx plus c, let me just change to y is y1, or y minus y1 is m into x minus x1. This information is available on your information sheet, which is what other people call the formula sheet, right? So you will be able to see these kinds of equations. They help you in case you forget them to know what you need to figure out in terms of finding the equation of a straight line. So what am I substituting here? We're just going to sub for y1. We're also going to sub for x1. That's where point P comes in. And we'll also sub for m. So those are the only things that you people need to change. So I'm going to have y minus 4 will give us plus 4 equals to the gradient is a half into x minus 4 is plus 4. Scofield swapped the numbers. The y value is 5, not 4. The y value is 5. Y is plus 5. So that actually has to be y minus 5 equals to the gradient, which is a half into x minus. That's where it's going to be plus 4. That is plus because it's a negative times a negative. Beautiful stuff, right? So now you're going to have y minus 5, beautiful people, is half of x plus half of 4 is 2, which you could then add 5 on both sides of the equation and end up with half of x plus 2 plus 5, which gives us an answer of 7. Just by the way, right? I've got the equation, I'm done. They said in the form y is mx plus c. I did succeed to express it in the form is y equals to mx plus c. When they say express it in this form, they do not dictate how you should start solving the equation. They are dictating how they want it to look at the end. How you're going to start working on it, the approach, it doesn't matter. You could start the way I did it, there's nothing wrong with this. You could have started with y is mx plus c, there's still nothing wrong with this. The whole thing of saying in the form y is mx plus c just tells you how we want to see the final answer, right? What is the other way they could have asked you to express the final answer? Well, they could have said to you in the form, this is the other form, they could have said in the form ax plus by plus c equals to 0. Now, if they want it in this form, it just simply means that you need to change this from what it is and re-express it in that format. So if I wanted to do the same on what I'm looking at there, I would first of all notice that there is nothing that is supposed to be on the right-hand side, which means all my terms need to go to the left, right? I hope this is going to add value for you, Kenny. I would need to move everything to the left. So that half is a positive. It was going to be negative half x. The y value would still remain as y, and the constant, which is 7, is going to be minus 7, is equal to 0. The other thing is, when I look at what they want me to express here, I don't have fractions, so which means I can double everything. So which means I can double all these terms, and this will be minus x. If you double this one, you'll have 2y. If you double 7, you'll have 14 equals to 0, excuse me, because the double of 0 will still amount to 0. So this is how you could also express the equation of the straight line, and the examiner dictates how they want you to rewrite the final answer. So please respect those people. They want you to do what they want you to do, so please do exactly what they want you to do. Right, the follow-up question says we need to find the size of PKR. Okay, PKR is an angle. We need to find the value of angle PKR. Okay, cool. Right, now, where is angle PKR? Now, analytical geometry is done. What I'm about to do here has nothing to do with analytical geometry. It's now going to be my analysis using other concepts of math. The examiner wants you to find the value of PKR. We're looking for an angle PKR, which is at the bottom, right? Let me write it in green. They want this angle here, in this corner. That's what they want. They want to know how big is this angle. Now, there's many ways I can find this. I can use trigonometry. I can also use Euclidean geometry, right? Okay, now let's look at theta. If I was using theta, I'm going to narrate it for you so that you'll understand, Kenny, what you could do. If I use the fact that theta is the angle of inclination, right, of the line PK, I'll be able to find what theta is using angles of inclination. And when I have that, I'll be able to then take it and transfer it this side. I'll find this small piece here, okay? And once I'm done with that, then I'm gonna obviously use the fact that that small dot there is vertically opposite to the other small dot that I can have in that small box that is lying right there inside. In fact, I'm going to use that and enlarge that small triangle that you see there at the bottom. Allow me to enlarge it. Please look at it very carefully. Look at that triangle very carefully. I'm going to enlarge it so that you guys can see what is going on, right? Let's enlarge that triangle so that you guys can see. That triangle looks as follows, right? There's the x-axis, there's the y-axis, right? I'm enlarging that part so that you guys can see. And then there is that diameter that goes like this. The diameter makes an angle here of theta with the x-axis. There's point K here and there's the origin here. At the origin, beautiful people need to know that the y-axis is perpendicular to the x-axis. I'm looking at this question, I'm laughing because there's like 7 ways I could have done it. 7 different methods I could have engaged in order to figure out what the solution is to this. But I'll take the one that is quicker, right? Okay, so theta is the angle of inclination. We're interested in this angle here, which I'm going to call alpha, right? We want to find alpha, right? Okay, cool. But now I need to find what theta is. There's a reason why this was on the diagram. So I'm going to start by saying, first of all, the tangent, right, of theta is equal to the gradient of the diameter, right? The gradient of the diameter, which means the tangent of theta, I'm using the angle of inclination, is -2. We found the gradient a long time ago as -2, which then means my theta will be the inverse tan of -2, right? Plus something here. Very important for you to keep this in mind, okay? When you work out angles of inclination, right? When you work out shift and then you press tan and then you put -2 or negative anything in your calculator and then you press the equality sign, you will notice that your answer comes out negative. Why is it coming out negative? Is because on the cast diagram, this is 0 degrees. And then if you're going this way, you're going in the positive calculation of your angles. That's why positive 90 degrees will be there. But if you went this way, you would be then going in the negative direction of calculating your angles. Now, if you look at this, right, I just got -63.43 degrees. That is an angle if I'm not calculating anti-clockwise. It is an angle you're getting when you're calculating clockwise, right? I'm going to do it in a way that you guys were taught at school so that you'll see that my argument holds, even though I'm using the ideas that you were taught when you were in grade 11. In grade 11, you were told that if your gradient is negative, your angle comes out negative. So you're going to need to add on the answer there that you're getting, right? You're going to need to add 180 degrees. Why? Because angles on a straight line add up to 180. The theta angle that I'm getting and the one that I'm claiming will be the negative version of that, right? Basically on a straight line. That's why I'm adding 180 because angles on a straight line must add to 180. And you're getting an angle of 116.57, right? When you add 180 on this, you're going to get 115.57. Very important, right? 115.57. Is it 57? Yes, 116. Yes, 116.57. 116.57 degrees. That's the angle theta. 116.57 degrees. Now, we don't want that. We could probably be interested in figuring out what this one is. If I found that, then I'm going to use sum of angles of the triangle in order to get what alpha is going to be because it then becomes Euclidean geometry. Very simple, no complications. But then I'm going to use another concept, which is the exterior angle of a triangle. You people know that if you've got a triangle, right, and you've got an exterior angle, this is the exterior angle, right? Let's assume that the interior angles are maybe angle A and angle B. The sum of these interior angles will be equal to the exterior angle. So this is simply A plus B. Okay? When you add those interior angles, it will give you the exterior opposite angle. Now, according to this drawing, theta is exterior of triangle, the triangle that you guys are looking at. And the interior angles are alpha and that 90 degrees that I have there. So I'm going to use that argument. I'm going to say to the examiner, alpha, right, added with 90 degrees will give us theta. Why? Because the exterior angle equals sum of the interior opposite angles. Very powerful. Okay, cool. We are looking for alpha, which means alpha will just become 116.57 degrees minus 90 degrees, minus 90 degrees, which then makes that alpha there to be, let's go back to the calculator, it still has the number we're looking for, so I'm going to say this number, remove 90 degrees from it, we end up with 26.57, so your answer is 26.57 degrees, and that will be the solution to the angle that the examiner wanted. They wanted you to figure out the value of PKR. Right, so PKR, that means PKR, just answer the question they asked you to answer, is equal to 26.57 degrees, and that will be how you would need to engage the arguments that you're currently working on in order to find the story of what is happening here.